All right, this is section 2 of chapter 3, Rolle's theorem and the mean value theorem. So let's start off with Rolle's theorem. This is a little hard to read, I'm sorry. Let f be continuous on the closed interval a to b and differentiable on the open interval a to b. If f of a equals f of b, then there is at least one number c in a to b such that f prime of c equals 0. Basically this says if you have two values that have the same 2 points that have the same y value, somewhere in between them there must be a relative maximum or minimum. The derivative must equal 0 somewhere in between. So let's find the two x-intercepts of this function and show that f prime of x equals 0 at some point between them. So, let's see if that helps a little. To find the x-intercepts, we set our function equal to 0. And then we solve it. We can solve this one by factoring. X minus 2 times x minus 1. And then we get x equals 2 and x equals 1. So my two x-intercepts are 2, 0 and 1, 0. There's the first part of the problem. The second part says to show that f prime of x equals 0 at some point between the two x-intercepts. Well, our function was a polynomial, and a polynomial is always continuous and differentiable. So, since it's continuous and differentiable everywhere, it's continuous and differentiable on the interval in between those two x-intercepts. So it is continuous and differentiable on the interval a to b. And I know that a to b, what am I doing here? I want 1 to 2, those two x-intercepts. I know f of 1 equals 0 and f of 2 equals 0. Since those two equal the same thing, Rolle's theorem applies. Therefore, f prime of x equals 0 for some value of x in the interval 1 to 2. Somewhere between 1 and 2, the derivative must be 0. That's all this says. It doesn't say where, it just says it must be. So for our next question, f of x is x to the 4th power minus 2x squared. We're going to find all values of c in the interval -2 to 2 such that f prime of c equals 0. Well, the first thing I would do is verify that Rolle's theorem applies. Because Rolle's theorem is what guarantees that the derivative equals 0 at some point in between. So I just want to find f of -2 and f of +2. Well, use my handy dandy calculator for that. F of 2 is 8, and f of -2 is also 8. They equal the same thing, so Rolle's theorem applies. There must be a point in between -2 and 2 that the derivative equals 0. So let's find the derivative. It is 4x cubed minus 4x. And I want to know when that equals 0, so I'm going to start factoring. Take out the GCF, which is 4x, leaves me with x squared minus 1. And x squared minus 1 factors into x plus 1 times x minus 1. So the derivative equals 0 when x equals 0, -1, and +1. All of those are on my interval -2 to +2, so those are my three answers. Now we're going to talk about something called the mean value theorem. Notice the stars, it is very important. If f is continuous on the closed interval a to b and differentiable on the open interval a to b, so it's continuous and differentiable, then there exists a number c in a to b such that f prime of c equals f of b minus f of a over b minus a. Remember, this is slope. And slope is an average rate of change. So what the mean value theorem says, if our function is continuous and differentiable, there must be a point where the instantaneous, whoa, can't spell today, instantaneous, there we go, rate of change equals the average rate of change. So the mean value theorem says if it's continuous and differentiable, there must be a place where the instantaneous rate of change equals the average rate of change. So here's our problem. F of x equals 5 minus 4 over x. We're going to find all values of c in the open interval 1 to 4 such that f prime of c equals f of 4 minus f of 1 over 4 minus 1. We're going to find all the values between 1 and 4 where the instantaneous rate of change equals the average rate of change. Well, first thing we need to do is figure out what that average rate of change is. So f of 4 is 5 minus 1, so 4. F of 1 is 5 minus 4, so 1, over 4 minus 1, which is 3 over 3, which is 1. We're trying to figure out where the instantaneous rate of change is 1. Well, instantaneous rate of change is a fancy way of saying derivative, so we take our derivative. F prime of x, well, the derivative of 5 is 0, minus 4 over x. So let's remember that 5 minus 4 times x to the negative first power is the same thing. Bring down that negative 1, I get 4x to the negative second power, which is 4 over x squared. I want to know when 4 over x squared equals 1. Well, I'd multiply my x squared over, and then square root, so x equals positive or negative 2. That's not my answer yet, because I care about the interval 1 to 4. And only one of these answers is in that interval. Positive 2 is my answer. The only place that the instantaneous rate of change is equal to 1 on the interval 1 to 4 is at x equals 2. So why might I ever want to apply that? Two stationary patrol cars equipped with radar are 5 miles apart on a highway, as shown. As a truck passes the first patrol car, its speed is clocked at 55 miles per hour, so it's not speeding. 4 minutes later, when the truck passes the second patrol car, its speed is clocked at 50 miles per hour, also not speeding. Prove that the truck must have exceeded the speed limit of 55 miles per hour at some point during the 4 minutes. So, first of all, we have a continuous function because the truck is not disappearing off the face of the earth or jumping somewhere. And it's differentiable because the truck is moving at steady paces. So continuous and differentiable. That means that the mean value theorem applies. The mean value theorem says the average rate of change equals the instantaneous rate of change at some point. So if I can prove that the average rate of change is more than 55, the instantaneous rate of change must have been more than 55 at some point. So let's find our average rate of change. Well, average rate of change for miles per hour is how many miles he went in how many hours. Well, he went 5 miles because it says they were 5 miles apart. Miles over hours. Well, he was 4 minutes. So 4 minutes is 4/60ths of an hour. So we have 5 divided by 4/60ths. I would simplify my 4/60ths, that is 1 over 15. And to divide by a fraction, we multiply by the reciprocal. 5 times 15 over 1 is 75 miles per hour average. Well, by the mean value theorem, MVT, the truck must have been driving 75 miles per hour at some point in those 5 miles, or those 4 minutes, whichever way you want to say it. That's how the mean value theorem applies, and that's how you get a ticket if the police are really doing the math.